So in the last video, we looked at how to make power using steam and where all of the heat is consumed in the industrial process. In this scenario, all or most of the condensate returned back to the system. However, if we have no requirement for the low pressure steam downstream, the steam must be changed back to liquid before re-entering the boiler. There is still some enthalpy in the exhaust steam, and we want to extract as much energy as possible and transfer that energy to the turbine to increase the power from the alternator. The way that is done is to cool the exhaust steam. This creates a vacuum and further drives the turbine to maximize the output. The exhaust steam is cooled in a surface heat exchanger where cold or cool water runs through tubes inside the heat exchanger, picking up the heat from the exhaust steam. The water leaves the exchanger and travels to a cooling tower where the heat is rejected to the atmosphere before then returning back to the heat exchanger to pick up more heat. So in this heat rejection process, we want to wring out all of the energy from the steam. We have a term for this energy in the steam. It's called enthalpy. So we want to reduce the enthalpy of the steam to the lowest we can economically. When we do this, we will create a vacuum measured in inches of mercury or negative PSI. The colder the water, the lower the vacuum, which maximizes the available output. So let's look at this process in more detail. We will pick an example. Let's say we have a boiler that makes steam at a pressure of 650 psi and a temperature of 775 Fahrenheit. And for the sake of the example, we will say that the boiler is capable of producing 60,000 pounds per hour of steam. And we want to exhaust at a realistically economical number. So we are picking negative 12.8 psi, or about 4 inches of mercury. If you go to the website that is shown in the link below, you can plug in the data in this example. You have to make some assumptions for efficiency, and that is something that depends upon the size of the turbine and whether it is condensing or a back pressure design. In this case, we will use 79.5% efficiency for the turbine and 96% efficiency for the alternator. 4 inches of mercury is approximately negative 12.8 psi. In this example, we will find that we can make about 6,158 kilowatts of power. The software also shows that the enthalpy of the exhaust steam at negative 12.8 psi is 1,035 BTUs per pound. Multiplied by 60,000 pounds per hour means we have to reject 62.1 million BTUs per hour of heat. In the next video, we will elaborate on what that might look like.